I'm going to do is fill that GC mass spec vial up to the top line with dichloromethane. And then I'm just going to take that little bit of residue that's in there and pull the dichloromethane up. Dissolve some of that. So we'll get a sense for the purity of our chromatograph starting material. So we'll set that aside. And now I can stopper this back up. We've got plenty more material. Guess I have to run this reaction again. Get that put away. So up around 140. I'd like that to stabilize a little hotter than that. So while we're waiting, put nothing aside. Out of here. Get another micro spatula out. We're just going to add approximately the same amount of this material to each test tube. So it'll be easier to have them in this row so I can see what I'm doing. And we're looking at kind of a non-heaping spatula full in each case to get about that 50 milligrams. At each time point, we're going to take out a half milliliter aliquot of the reaction mixture and add it to this potassium carbonate to immediately stop the reaction by quenching the para-toluenesulfonic acid. Or vortex to mix, and then we will centrifuge it, take the supernatant and put it in a mass spec vial. A little skimpy on that second one. And dilute it up with dichloromethane so we can set up a batch file to run overnight with all our samples. One more test tube, since I'm using that one for that looks like about the same amount in each of those tubes. So I'll have A through O. And then in the mass spec, I'm actually going to have a 52A as well, because I'm going to run the TLC sample that I made yesterday of 52A before the purification and see what that looks like. So I'm going to grab this whole set of mass spec vials. We've got 52A. Grab another pipette. This sample is way too concentrated for mass spec. Mass spec is much more sensitive than TLC. So again, I'm going to fill that to the second line, maybe a little more. About halfway between the second and third line. Dichloromethane. And then just add a little bit of the ethyl acetate solution of 52A. So I have a GC mass spec sample of both my crude and purified product before and after column chromatography. It'll give us a good sense of how effective that purification process was. So there's 52A and 52B. You, of course, should be using your own lot numbers, not mine. So we're now at the 150 temperature that I want to be. And it looks like that's a setting of about 250 on the hot plate. Just going to leave that a little bit to see if that temperature stays constant or rises a little bit. And while we're doing that, we can prepare the rest of the GC mass spec vials that we're going to need for each one of these time points. So we're going to need 15 of these. I think that's 15. And those are going to be 54A through O. I need one more. I'll cap each of those up. And I'll set those in here. C. B. For D. Once I start the timer, obviously I can't stop, so it's important to have everything prepped before I actually start the reaction. above 150. I'm going to just turn that down very slightly. I want to maintain a constant temperature. So I have 54 A, B, C, D, E, F, G, H, I, J, K, L, M, N, and O, and then here A, B, C, D, E. So this tube will go in there eventually. And then these two are my crude and purified product. This is my pipette for the methylene chloride. I don't need the potassium carbonate or the para-toluenesulfonic acid anymore, so I can put those back where they belong. But what I do need is a vortex mixer, and I might as well move that into the hood. So I'll be able to mix that every time. Here's my para-toluenesulfonic acid monohydrate waiting to be added. Ready to go when we need it. And we're at about 152. So we got just a little. And I will restart the video when I actually start the addition.